For the, what, JV basketball people?
Yes.
JV basketball? Who left early. This is very exciting. I was just telling them this. 4-7 notes has 3 examples and nothing on the back side. So this is just a one-sided notes even. Yay! Your homework assignment is only 6 problems. Only 6 problems. Your homework assignment is only 6 problems. So that's exciting. Okay? So 4-7, they give you a vocabulary word, polynomial identity to start with. Okay, so let's talk about polynomial identity. You've heard the word identity before, and it basically is talking about yourself. Like if you have identity theft, your like personal information has been stolen, right? Identity theft, that's what it is. So, but an identity in math terms is like when comparing two things. I'll say when comparing two things. Okay, this is really delayed, sorry. When comparing two things, both are equivalent. Okay, when you're comparing two things, both of those things are equivalent. They are considered to be an identity if they're both the same on both sides, okay? Same on both sides. So I'll give you an example of that up here at the top, just real quick because it's a short one. And let's say I have x squared minus 4. X squared minus 4 is a special guy. Like, let's say I would go to break him down. What is x squared minus 4?
I don't know.
You don't know?
Oh, the x2.
You're close, kind of.
Okay,
So I'm going to break it down.
4 over.
That's one way of doing it. It's a what?
Perfect square.
You're close. You're close. It is a...
Imperfect square.
No. Something with square.
Square.
He's not a simple trinomial. He's not a complex trinomial.
It's a square.
What did you say?
It's a square.
Oh, kind of.
Perfect square.
He's a difference of squares. Oh my goodness sakes. He's a difference of squares, okay? And when I break him down as a difference of squares, okay? Like if you take the square root of x squared, what's that? X. And the square root of 4 is 2. And one of them is positive and one of them is negative. Okay? It doesn't matter which. It doesn't matter which. So this is an example of an identity, okay? The stuff that I have on this side, x squared minus 4 is the first piece. And the stuff that I have on the second side is the second piece, right? And even though those things look different, they are the same, right? They are exactly the same, okay? So that's what we're doing in example 1 and example 2. We are trying to take one side and make him look like the other, okay? So in the first example, let me turn the exposure up. I'm kind of dark up there. Okay? In the first example, the right side. Take a look at the right side. X squared plus 2xy plus y squared. He doesn't have any parentheses in him. Can you combine any of those like terms? Yes. No, you cannot. So he cannot be touched. He is done. You can't do anything to him. But what I can do is on the left side, we can simplify this guy. Okay? So what does it mean when it says x plus y squared?
Do it times 2. Foil it.
Yes, x plus y times itself 2 times, right? So that's what I'm going to do. I'm going to take x plus y times x plus y, and we're going to foil that thing and see if he turns in. So x times x, let's just foil. X times x, x squared. What about x times y?
XY.
Yep, you just write it as positive xy. All right. Then the last, the o and the I, or il, I guess, the insides and the last pieces. Y times x. Xy, if you want to, you can flip those around. And then what's y times y?
Y squared.
Y squared, okay?
So it's x
now that doesn't exactly, just wait, that doesn't exactly look like the right side.
That's because you have to combine.
But I have to put those middle 2 pieces together.
It would be x squared plus 2xy plus y squared.
And does that look like this piece?
Yes.
No.
You betcha. Done. He is done. So we have proven that he is an identity. So here's the deal. This might feel kind of weird to you, but the answer is like in the work of it. You have to work it out to show that this guy turns into that guy.
So there isn't really any answer.
So
you just have to
really,
work.
you kind of know when you get the right answer, right? Like if it doesn't turn into that,
then you
know you didn't do it. You didn't multiply it right. Okay. So let's go down to example 2. Now this one, you're transforming both sides. Okay, so we're doing each
What?
side kind of a little bit at a time. That's a
You
lot
have
of
to foil
stuff.
both of them.
Okay, just wait. So that's a lot of stuff going on, all right? So let's do this. Let's do this. We're going to look at each side. Here's my equal sign, all right? And I'm going to do the red side over here, okay? I'm going to do the red side over here, and then I'm going to work with the green side, okay? And just because he's so big and long doesn't mean I have to multiply everything out together, right?
Oh,
just
well.
because that's all like a big, long equation, I don't necessarily have to multiply everything together. So let's do this first, okay? Let's
Write it out.
focus on this guy, okay? Because this stuff over here I can't really do anything with, right? This stuff I can't do anything with. So x plus 1 squared,
Foil it.
let's foil it. X plus 1 times x plus 1. Okay, I'm going to do it over here. So x times x is x squared. X times 1
Plus X.
plus 1x.
Plus X.
Sorry, I'm really delayed on this video. 1 times x is another 1x. And 1 times 1 is just 1.
1.
Is just 1.
Bro.
So now I put my middle two pieces together and I get x squared plus
2x
2x.
squared.
Nope, not
No,
squared.
never mind.
You're just adding.
Wait, but
Plus
it
1.
equals the other one.
Oh my gosh. Oh my gosh.
So
Oh
now
my gosh.
This
Hey.
one will have to
Wow. Oh my gosh. Okay, so you guys were already starting to figure it out. So this piece right here, we just did that, and he became this guy. So I'm going to just rewrite this one down here. X cubed minus 6x squared plus 12x minus 8. And some of you guys are already figuring this out. I could multiply those two big, huge, long pieces together, but I don't want to do that because that's a lot of work, right? That's a lot of work that I don't want to do. So what you've noticed is that this piece right here, x squared plus 2x plus 1, is the same as x squared plus 2x plus 1 over here. So in order for these two to match up, what has to be true? The other one has to be the same. So I need to figure out what this guy is and make sure that he matches up to be this.
Wait, you have to foil
Right?
it 3 times.
So I have to foil it 3 times, okay? So I'm going to do that 3 times. It's not as hard. It's not hard. It's not hard.
Are you sure?
I'm
The
sure.
math teacher.
X minus 2 times x minus 2 times x minus 2, okay? Do not try to do all 3 at one shot. You cannot do it,
Yes, you
okay?
can.
No, you can't. No, you can't.
Foil it now.
Then you're doing it wrong. You're not doing it right.
Wait, how
Can I have whiteout?
Just cross it out.
Hey,
Okay.
so
So-
you foil the first 2 and then take it times the third one.
That's exactly right. We're going to
Oh,
foil the
yeah.
first 2, take it times the third one, okay? Foil the first 2. Okay, so we're going to multiply those 2 together. X times x is x squared,
Minus 2x.
okay? X times negative 2 minus 2x.
Minus 2x.
Oh my gosh. Minus another 2x
Plus 4.
plus 4. She's got it.
And then
Wow.
you take
Just wait. Oh my goodness.
Minus
Mallory.
4x.
Just wait.
Oh my gosh.
Just wait. Okay, everybody get to this point. Everybody get to this point. So now, what I could do is I could take this, the way that it's written right now, times
But
x
you want
minus
to
2.
combine the middle 2.
But you want to combine the middle 2 pieces so that it's less work later on. So
X
let's
squared
combine those
minus
2.
4x.
Okay.
Plus
Oh,
4.
Mallory. Oh, Mallory.
And then
Okay,
x minus
now I'm going to multiply by x minus 2.
Whoa.
Okay, there it is.
X
Now,
times the third.
just wait. Shh. Mallory, I'm shutting you down. Be quiet. You're shut off. Zip. Okay. You can keep going, but we're gonna slow down. All right. So now I'm gonna multiply those together. Okay. I have something that is 3 pieces right here. 3 pieces times something that is 2 pieces. So how many pieces should I end up with?
6.
6. 1, 2, 3, 4, 5, 6. We're gonna write out all 6 of our pieces. Okay. So first I'm gonna take x squared times x.
X to the third.
X to the third. Okay. Then what do you normally multiply next?
4.
What do you multiply next?
4x.
You take the 4x
Oh,
times
no.
the x.
X plus
It doesn't matter. Just as long as you're going
X
north.
two.
The 4,
times the 2.
Okay, so you do negative 4x times x. Okay,
No.
that's the way a lot of the kids in the other class do. Just wait. It doesn't matter what order you go in. So negative 4x times x is negative 4x squared. All right? Then I do 4 times x. It doesn't matter as long as you multiply everything by everything else. So 4 times x is plus 4x. Doesn't matter. Okay, now what do I need to multiply everything by? The negative 2. That's exactly right. So x squared times negative 2 minus 2x squared. Okay? Negative 4x times negative 2. Positive 8x.
8x.
And then 4 times negative 2?
8.
Minus 8. Okay? Now I'm going to combine my like terms. Yeah? So x to the third,
Minus
I'll write this over
2x.
here.
Oh, wait, plus 2x.
X to the third is there, okay? But then I've got negative 4x
Plus
squared
2x squared.
minus 2x squared. Negative 4 minus 2.
How do you-
Nope, you didn't say right.
Oh, wait, no, it is negative 6.
Negative 6x squared, you betcha. Okay? Then I've got positive 4 and positive 8x. Plus
Hey guys, it comes out the same.
12x. Okay? Minus 8. There he is. Okay? And the front piece, I'm just going to leave him alone. X squared plus 2x plus 1. Okay? Now, I could multiply those together again, but
We don't feel like it.
I have proven that the first piece looks like the second piece, right? Does the stuff on the left look like the stuff on the right?
No.
Yes, so I don't need to go any further. I don't even need to multiply the stuff in parentheses. He is done. They look the same, right? They look the same. Okay? Next, last thing, they are giving you an identity here, and they are saying rather than multiplying the stuff on the right side together and showing that it looks like the stuff on the left, let's do this. Let's plug a number in here, and let's plug a number in here, and see if they come out to be the same number, right? If those things are truly equal, whatever you get on the right side should be what you get on the left, right? And vice versa, right? They should be the same. So what we're going to do is we're going to plug each one of these numbers into the left. We're going to plug each one of these numbers into the right. Show that they're the same, and then if we do that, then those things are equal to each other, right? So we don't have to make the one look like the other. They're just equal to each other. So the first one, if you plug in 1 for x, this would be 1 to the third power minus 10 to the third power. That's what you plug in, okay? That one you might be able to do in your head. 1 cubed is 1. What's 10 cubed? Like 10 times 10 times 10, 1,000. What is 1 minus 1,000? But it is negative 999, right? Negative 999, okay? Now, take your calculator out and plug those numbers in. 2 and 15, 3 and 20, etc., right? Okay, as soon as you plug it in the first one, you should just be able to go back through and change your numbers, right?
Yes.
Okay? So plug some of these numbers in. Do we want to like divide and conquer? Does everybody want to plug everything in?
You see, Emma has my calculator.
See, I have a calculator here.
Why does she have a calculator?
Because she paid for it. And then I forgot to grab it out and come back.
There we go. It's not as good as what yours probably is, but there you go.
It's the same thing.
Okay. So plug those numbers in, see what we get. Yes. Okay.
Stop.
When you plug 2 and 15 in, what do you get?
Negative 3,367.
Negative 3367. Did you get that?
Yeah.
And then negative
Liar.
7973.
Negative 7973.
Wait, y'all are going too fast. Why
Okay.
are you going so fucking
Negative
fast?
7973.
Negative
Trinity, or Tegan's just on top of it. What?
Negative 15,561.
Negative 15,561. Okay, last one.
Negative 26,875.
Negative 26,875. Okay, so those are the numbers that we get on the left side when we
Hey,
plug
just
those
one
numbers
more
into the left
And
side.
they're all the same on the
Are they all the same on the right side? Now, this is really important. This one is saying use a table to determine whether these are the same. So they are not automatically telling us that they are the same. So we do need to check all of them. Just because they work for one point doesn't necessarily mean they work for the other point, right? Or another point or another point, okay? Up above here it said prove that those are identities, right? What does that mean? Prove that those are identities.
Say yes or no.
Well, no, prove that they're identities means we already know that they are. We already know that they're the same, right? If it says determine whether they're identities, we don't know whether they are or not. So this is a yes, because after we plug these in, they are negative 999, negative 3367. But you need to check all of them, because we are not assuming that both of them are the same.
But they are, I just.
They are, yes, they are. But this one, because it says determine whether they are, we don't necessarily know that they are exactly the same. Because the table comes out nicely, we can now for sure say that they are. They are identities of one another, right? Okay? So let me show you your homework assignment. I will tell them on the video what they have to do. Okay? And I'll show you how this works. Actually, just wait. I'll put this up on the video so then I can stop it. Okay, so here's the deal. On 4-7, there are 8 problems on here. You can skip number 3 and you can skip number 7. 3 and 7 you can cross out. Okay? All right, so now the question says, transform one side of the equation to determine if the polynomial's identity. Okay? So, does that mean that we necessarily know that they work out on both sides to equal the same thing? No. So somewhere in here you're going to have to put yes or no, right? Like yes, it shows up and it's the same on both sides, or no, it's not, right? So you need to include that in your answer, yes or no, after you worked it out, right? If you give me your paper back and it just says yes or no on each one, I'm going to toss it in the garbage, okay? So make sure you work it out, work the problem out, and then you will have to say yes or no. What about this bottom part?
It's the same thing.
It's the same thing. We don't know for sure. It says determine if they are. We don't know for sure that they are. So this is a yes or no also. It might not work out that both sides are the same. If that's the case, then it's a no. They are not identities. Yes? Does that make sense? Okay. All right. I'm going to stop the video. There you go.